Hi, let's make an overview of what is possible to distill from patent data. Case study, solar panel. Solar panel in only title. So what do we have? We have about 7,700 patent documents. Now, to be sure that we have all the necessary documents, there is an AI tool which is called Find Related Terms, which will try and search for you all the terms, so solar panel, that have the same context, that are related. So you can see, of course, solar panels, but also photovoltaic system or panel or array. So you can choose the ones that you would like to add to your search and then update that. And of course, I'll have about a bit more. So that's 12,000 patents here instead of 7,000. Now, this is where the problem starts. Let's see how we can make some sense of the nonsense, because we're not going to read 12,000 patents. So there is a set of visualizations in which you can choose, for example, to filter all this data in a graph into, for example, who is patenting where. So what are all the countries they are patenting? For example, here, Finland, 6 patents where they have solar panel in title, as we have asked. So you can always go in detail in these patents by just looking in detail and then find the actual data behind it, or just to know. And what you have often in these visualizations is that you have a word cloud. So the bigger basically the word, the more patents behind the visualization. And you can start comparing. You can say, well, actually, I would like to know, instead of bibliographic, I would like to know, say, who company-wise is working together with who academic-wise, to see a bit the link between industry and academia. But in this way, you can compare anything versus anything, company versus country, or fields, or trademark. So any kind of XY you can think of. Like I was saying here, the academics are here, University of California, for example, here, and then the companies are here. So you can basically look in an XY bubble chart or heat map, who is working with whom. Furthermore, you can start to look in time. For example, what is the activity? So over time, what is happening in a certain domain or certain companies? So in this way, you basically have more of a XY diagram like that over time. You can choose which ones do you want to see in there. Say, for example, you want to have in there a company called BP here, and you say add them in there. And you can have a view like this, or you can have a view in more bubble charts to see a bit the evolution of these patents, how they go up and down. So you see, for example, here in title, solar panel, General Electric, starting here in 2010 and going up and then down. So this way, you can basically slice and dice the data and make visualizations that make sense to you. And in this way also, we have created a set of maps. So maps are basically visualizations that we say, okay, it is quite easy to have a look at what are all the elements used in, and here I have asked for a map that we know, the table of Mendeleev, and immediately you can see in the way we have looked in title and abstract only, and we say, okay, in title and abstract we have 21 mentioning of titanium in the patents that are mentioning solar panel, or geranium here, germanium, 3 patents, so it can show you where it actually is mentioning that. So very quickly you can say, this is my visualization, my top visualization, and I go into the data. Just like I could say, this is all the materials that I'm clustering, and I can go into the data by clicking on them. Or I can list them up and say, I want to see which ones are you working with PTFE, for example. You immediately get, these are all the patents working on PTFE. Now, one innovation which can be interesting is to find out domains. So in which domains are they patenting? For example, here you have the domains of human necessities or transport or construction, and you can see basically in which domains they are patenting in frames, but also in layered products or in electrical data processing. So you see a bit the angles of what solar panels are all about by seeing in which domains they actually have kind of intelligence or patents. Similarly, I could make a domain map. Let me make that from solar panels. That is here. Domain player, and say solar panels to see a bit in which domains. Voilà. I'll add a few more things while we're at it here. So in this way, you can basically have a look at all these visualizations. For example, say what are all the classifications in the domain. So there's a map of all the classifications that are existing, A, B, C, D. So this is basically how patents are classified. So in B, you have again sub-classifications. For example, B07 here, which is about cleaning. And then you have in B07C, you have postal sorting or bulk material and so on. So all the time you go deeper into the classification, you can basically see where exactly the patents are placed. And on that you can then place, for example, say where is Bosch here, and if you want to compare Bosch, say for example, with another applicant, where is General Electric, you can put them here, and then in this way you can see, okay, who is patenting with whom, or in which classes are they both patenting, in which classes are they singular patenting. And you could add, for example, I want to see who's talking about, say, self in a title, for example, or in title and abstract, and then any kind of word you can say, you can see where are they talking about self, something, a self function. A self function, as you know, it's a bit of a direction, and it will be a text analysis that we will do. Here we have it. So basically you can say the direction of self-cleaning, self-containing, self-locking, self-powering, self-porting in the domain of solar panels is quite present. So like that, basically you can visualize already quite some data into either maps or into word clouds or into graphs. Things like what are the fields that people are working with. For example, acoustic fields, ultrasound, 93 patents. So you can go exactly in the fields there that they are mentioning here, surface ultrasonic scale prevention, whatever the link is here. So every time you can see the link here, the photovoltaic array, and the link onto ultrasonic welding here in the patent. So the data, big patent data is there, but there's no use if we cannot go access it quickly. But if we can access quickly, say for example, solar panels, what are they doing? Oh, they're into cleaning, into equipment, they're in for cosmonauts here even. They're into magnetic variables, they're into semiconductors, and so on. So once you see those, you can then look into other domains. Where are they actually doing the same, and can we get some data from that? So there's many ways to visualize that, and especially when you go into text analysis. For example, I can ask what kind of, say, panels exist by saying adjectives in title and abstract, for example, or in title and abstract, we could say, and used in front of panel. So then I could get the type of panels which are there. I could also ask for problems. What are the problems that are solved, or the glossary, or any kind of text analysis. I could say, for example, what are the components people talk about. If you want to make a function map, a function analysis, what are all the components? So, and by asking, for example, what are all the problems, I immediately get, well, it's about, alignment problems or performance or removal, or what I'm getting is basically top 50 of top 100, all the problems people are discussing in the area of solar panels. These problems I could say, well, which company is working on which problem, for example. Or I could use them to say, now let me look in other domains where people solve a similar problem, like, for example, an alignment problem of materials. I also asked for what type of adjectives do I see here, top 50, top 100. So I'm, of course, having mainly photovoltaic and solar, but I can see there is some flexible panels, or there is some end clamp panels, or opaque, or thermal panels, or anti-theft panels. So I could look at anti-theft panels and see, for example, where do they mention anti-theft panel, so they can in their patent all the time talk about anti-theft close to panel. So there is many variations on how to basically look at the data. You can also have a look at what are all the units, say what gets measured gets done. Can I find out what are the main units for solar panels, and in this way see, okay, it's mainly about size or voltage or power. And if I want to know power, for example, I can see a list of high power, slow power, low power, and I can just click on them and find out where are they mentioning, for example, which type of powers. And again, we're slicing it here in 1000 megawatt as an example. Yes. Another example here is what direction are they mainly patenting in? So surfaces, shapes, flexibility, transparency, so integration. You can also see them in a word cloud. So you see a bit which are, for example, using porosity 2000 patents. So where they work on hollow, for example, solar panel would be an example of a porosity change. These are some of the examples of quick visualization. So in total or in detail, I think one of my other favorites is a map of competitors, and I'll use that as the last one. So say, for example, you want to have a competitor analysis of who is competing with General Electric, for example, but exactly in only this domain. So because they're doing many, many things, imagine it's only about solar panels. I want to know who is competing with them. Why is that an important analysis? First of all, it is done again with AI. It's a lot of factors to look at, comparisons between companies. With this set of patents on solar panels and General Electric, we find out that these are the closest, basically, competing companies. And sometimes these companies have only 10 patents, so they could be small companies and interesting to look at from the point of view of a big company. Like these are the bigger companies here, which have already 50 or more patents. Secondly, if you find the competitors of a client, if it's a client of yours and you're looking for new clients, well, you could ask for a competitor of your clients. If you need new suppliers, you could say, well, give me a list of competitors of suppliers, of my suppliers, so I could find cheaper ones. And it's only the patents that actually have this kind of listing in one click. You can get a list of competitors of a certain company if they're IP driven or technology driven. So you can see that patent data is actually much more interesting than big data in general, because it already has its structure and it has basically a lot of data. They say over 80% of the data in patents is actually nowhere else. So it's very close to a global brain that we could use as a smart colleague. And especially if we have already innovation methodologies at hand, trend analysis at hand, we make it very easy to actually distill the data out of patents to find out, for example, where somebody has already solved a problem like mine. Thank you.